So the first objective, solving graph inequalities, that one has been hit really hard in day one. Today we're going to talk about something called compound inequalities. Da, 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 da. So, compound inequalities. When you make a compound, well, when I was a pharmacy technician in the military, there were certain medications that didn't come from a pharmaceutical factory that doctors wanted us to make. And those were compounds because they'd say, put this together and this together and this together, mix them all up. One of the things they did back then had to do with people that got canker sores. If you've ever had a canker sore, those sores inside your mouth, they hurt like crazy. And some people get them all over their mouth and in the back of their throat and everything else. So we had a doctor who came up with his own little concoction of viscous lidocaine. You know, you guys might have beautiful teeth because they've done a lot in dentistry in the past 20 years. But viscous lidocaine is what they put on the little cotton swab and then put on your gums so that it doesn't hurt when they give you the Novocaine shot. Yeah. So he said, take a bunch of that and take these, they're called Carafate. It's medication for people with ulcers. It coats the stomach. So instead he was having it coat the mouth. Crush those up, throw those in there. And then he had us put some tetracycline antibiotics in there, which, we all know now that tetracycline is an antibiotic, and those cold sores that they had in their mouths, canker sores, were viral, but he didn't know that, so he had us crush those up in there. And yeah, his patients received some relief, mostly because of the painkiller, the viscous lidocaine that was in there, but at least it helped them out. That was a compound. We had to actually mix that stuff up in the pharmacy before we could give it to the patients. So this compound inequality is telling us more than one at a time. We're going to put a couple of these together and see what we get. Here it was. So part 2 is figuring out how do these compound inequality things come together. And there are 2 types. There are and inequalities, where this and that need to happen together. And my shoulder's giving a gigantic crack up here. We need to find the solutions that make both of the inequalities true. So one of the things that we could do is say, and we're not going to because we're not supposed to get up in social distancing and all that, is if you have tennis shoes on and you're wearing black, stand up. And there would be people that have both tennis shoes and have black on somewhere, and they would stand up. So that's an and inequality, when 2 things happen at the same time. So problem 5 says, what is the solution of 7 is less than 2x plus 1 and 3x is less than or equal to 18? And I would say, well, I don't know. They're not solved. So we have to solve them first. And we know we solve these just like we solve equations, except if we multiply or divide by a negative, we got to remember to flip the sign. So this little bugger here, we'd subtract 1. And then we divide both sides by 2. And then we'd say, that's backwards. I want to be able to read this so it's easy to graph. Well, remember, when you flip them, you flip everything, including the sign. So, x is greater than 3. Well, that's an open dot. And going to the right forever. That's what that one is. Along with that, because it was an and, 3x is less than or equal to 18. So we divide both sides by 3. Hey, I don't have to do any flipping on that one. That one's set to go. I need a closed dot at 6. And because it's less than or equal to, shade left. Now here's the problem. It said and. So only the stuff that's in both of these is the answer. Well, we better take a look. And it's easiest to think in terms of the number line. And again, I always say that, and then you guys weren't here yesterday. In the 5th grade, it was really exciting because my 5th grade teacher had a number line at the front of the room. So I'm sitting out there where you are, and I see 0, 1, 2, 3, 4, 5. And then I noticed -1, -2, -3. Oh, negative numbers? What are those? So we asked her about them, and she said, well, we'll be learning about those this year. So we waited and waited, and we finally learned about them. So every time I see a number line, I'm thinking about my teacher's number line at the front of the room. And if I were walking towards that number line, I would realize the green one's not graphed here. I keep going. Still no green. Oh, there's the start of green. But it's not included in this one because this one has an open dot. So I would have to put an open dot. I better change colors here. Open dot at 3. Because it's in the blue, but not in the green. And then I keep walking. Because now this is green and blue. And then I get to the 6, and 6 is in both of them because the closed dot means it counts. But if I keep walking now, I only have green. So to have it be in both, I have to see both colors, and they both have to have closed dots to include it. So at the 3, that's kind of like a cutoff because it wasn't included in the green. The 6, that was included in both, but that's the cutoff as you go to the right. So really, this is the solution. Now I look at that, and I want you to think of that as what I call an and sandwich. Do you see how and is in the word sandwich? Take off the S, it's right there, A-N-D. So this is an and sandwich. Our dots are the bread. And the coloring that we do in between, that's all the good stuff. The meats, the cheeses, the mayo, maybe not mayo, a little vinegar and oil, that type of thing. But that's where all the good stuff goes. So when we have an and statement, our graph should always look like an and sandwich. Bread, all the good stuff in between. Now, because it makes an and sandwich, what I want to do is I want to sandwich my variable between the 2 points that ended up being on the ends. So I realize I've got to put greater than 3, because when you make a compound inequality, you always read from the middle out. So x is greater than 3 and less than or equal to 6. So whenever we make an and sandwich, we have to make an and inequality. And it's still the sandwich thing. You know, you got the x sandwiched between the 3 and the 6. And then you notice, well, this one doesn't have an equals bar. Oh, that's right. That was a closed dot. It does have an equals bar on this one because, yeah, 6 is included. Closed dot. So that helps people out a lot. Because for some reason, remembering the difference between and or gets kind of tough. Just remember, the word and is in sandwich, and it makes perfect sense. Bread, all the good stuff. In there is our, pardon me, is our x's. Must be talking too much this week. So now we have got it. You're going to help me out a little more with this. What is the solution of this monster and this monster? Okay, let's put the first monster. I'm going to do green here. Up here. And the second one here. I don't think that's enough space, though. I write really big. So I think I'm going to cheat. Slide. Oh, I can't slide them. There we go. Unlock. Come on. Yes, now I can cheat. And move mine down. Hopefully you've got enough space. Okay, everybody's really good at solving equations and inequalities. So take a look at the green one there. What's your first step? You're adding 1 to both sides. Then you divide by 3. Did you do any flipping? No, that's a positive 3. But now I want to flip it the whole thing because I want to graph it. So it's going to say x is greater than or equal to 2. Open or close dot? Close dot at 2. Shade right or left? Right. X is greater than or equal to 2. Remember, we flip it around so we can graph it easier. So there's the green one. Blue one. What would you do? Divide by 2. Bill, you're not going to learn math that way. Get it in your pocket and keep it in your pocket. Open or closed? Open. Shade left or shade right? Shade left. Less than 6. All right, let's put our graph together. Let's see what's going to happen here. We're walking along the number line. Walking. Only blue. Oh, green and blue. First cutoff is at where? 2. Open or closed? Yeah, this time it's in both. We keep walking, so we're shading. And we get to the other end of where there is green and blue together. What's that other end? 6. Open or closed dot this time? Has to be open. It's not included in the blue one. That's what our open and closed dot means. Open dot means not included. That's going to be kind of hard to see from the back. Let me make that a bigger donut. There. There's a bigger donut. So now I see bread, good stuff in between. This is an and sandwich. X is between. Which number do we have on the left? 2. Need an equals bar? Yeah. Cutoff number on the right? 6. Need an equals bar? Nope. And sandwich. Works every time. So we see where they're both graphed at. And when I say both, I mean they have to both be colored at the same time. So that makes an and sandwich. If the variable part of an and inequality matches, which it did with us, it was x. We had an x when we got done. We collapsed it, and we made it into an and sandwich. But here's what they're saying. What if, when you looked at them, you saw 5 is less than x, probably better use, I don't know, maybe a different color is better for people that are gone. 5 is less than x plus 1, and you look at the next one and you see x plus 1 is less than 13, and the light bulb goes off. Boing! Wait a second, x plus 1 is in both of those. Then why not make the sandwich right away and say, hey, x plus 1 greater than 5 and less than 13. But how do we solve that? Well, it doesn't have 2 parts, it has 3 parts. So I look in the middle, because that's where my x is, and I realize to get x by itself, I have to subtract 1. Normally we'd say subtract 1 from both sides. This one has 3 sides. We have to subtract from all 3 parts. And we have a beautiful and sandwich. X is sandwiched between 4 and 12, which means, unfortunately, we have to add some numbers, don't we? We're a little short here. Okay, so should we put an open or a closed dot at 4? Open. Open or a closed dot at 12? How do you know? Doesn't have an equals bar. The extra equals bar means you have to do some extra shading. This doesn't have it. And if it's an and sandwich, where does the shading have to go? In the middle. All the good stuff. There it is. Now again, this is called a compound inequality because you can see how we put two of these together and we got one. But as we get better at it, they're going to give us the problem looking like that. And we need to know, hey, just work like always. Find your variable, get it by itself. Just make sure you do stuff to all three parts, not just to two parts. Everything. Keep it balanced. The ORs. The ORs come as separate inequalities. So OR inequalities, you need to find all the values that make either of the inequalities true. Before I said if you're wearing tennis shoes and you have black on, stand up. Those same people would not all be standing if I said if you have tennis shoes, or sorry, those same people and more would be standing if I said do you have tennis shoes on or do you have black on? Because then people are like, well, I don't have tennis shoes on, but, oh, I got a black mask, you know, and they could stand up. So, or is different. Now, this says, what is the solution of these two buggers? And then let's see what the graph of an or statement looks like. So they took 5 minus 2m greater than or equal to 21 and put it over here, so we've got some workspace. 4m minus 1 greater than or equal to negative 21, again, giving us workspace. 5 minus 2m is greater than or equal to 21. What are you doing? Because I know you're already solving it. Subtracting 5 from both sides. Then, oh, then we have to be careful, don't we? What happens when you divide by a negative 2? Flippity snippity. We got to flip. M is less than or equal to negative 8. Well, let's go solve the other one. Then we'll come back and do the graphing. How do you solve 4m minus 1 is greater than or equal to negative 21? Add the 1. Then, look at the green one. Divide by 4. Any flipping? Flip when we divide by 4? No, because we're dividing by a positive 4, so we don't flip. Well, look at that. We're only missing one thing. It had this little word that said or. So this is not an and sandwich. This is an or. So I start thinking, if an and sandwich graphs inward, what's the only place available for ors to go? Ors are for extremes. Ors, or for the temperature in Minnesota. That's what I always think about with ors. Either we get way down there in the negatives, or way up there. Although this year's been really weird, you know. Over the weekend now it's supposed to be in the 60s again. But that's Minnesota. We're extremes. So if M is less than, it makes us hardy, folks, doesn't it? We're hardy. We can take a lot. M is less than or equal to negative 8. Open or close dot? Close dot. Shading left or shading right? Left. Outward to the extremes, the really low numbers. The green one over there, where are we putting our dot? Negative 5. We're going to do open or closed? Closed at negative 5. Which way we're shading? To the right, because again, this is not an and sandwich. This is an or to the extremes. So it's heading out. So this one is more of a, hey, I'm solving two inequalities, and when I'm done, I really have two separate graphs. Whereas an and sandwich ends up being one connected little piece in the middle there. So ors tend to get forgotten because people are like, you know what? I didn't have to do anything new there. I know exactly what I'm doing. So don't mess them up with and. And is special. Alrighty. 7w plus 3 is greater than 11. How would you solve it? Subtract a 3. Any flipping going on for subtracting a 3? Nah. Then what? Divide by 7. Oh. That's not a nice integer. That's a fraction. Fractions happen. We got to deal. You know, we got to say, hey, I can deal with this. I got it. It's okay. I know this is a little bit more than 1. It's 1 1/7. I can do that. Or how we solving the green? Adding 1 to both sides. Then divide by 4. Any flipping? All right, here's what I know. I know this is easy for most of you. I know that because I'm watching and you're just scribbling like crazy. But you remember more when you ask and answer questions. So try not to get into your, I'm just going to stay in my little bubble and I'm going to do my math and all will be good. And speak, because that's going to help you remember. Brain research tells us that. Alrighty, my little red one. I said I'm going to have to try 1 1/7, and yeah, that's about right now. I don't know. There. Should I close that up or not? All right. Now, was I exact when I put that up there? So I better label it. People are going to want to know, what on earth are you doing? Yeah. And then that one says greater than, and we know it's an or, so we know it has to go out to the sides, to the extremes. Where's our dot go for the green? Open or closed? Which way do we shade? Yeah, out to the left. There it is. So there's our or statement. And that's, notice I wrote or up here. As long as you have it somewhere in the problem, you'll be okay. Oh, B looks interesting. Let me write this down in a couple of different colors. In the blue, I have 16 is less than 5x plus 1. What do you want to do? Let's subtract that 1. Do you have to do any flipping for subtracting? No. Divide by? Any flipping for dividing by 5? No. Most of the time you end up saying, why don't we ever get to flip? Well, now we can flip the whole thing. It'll make it a little easier to graph. X is greater than 3. Let's go to the green. We'll do all our graphing at once. 3x plus 9 is less than 6. Step 1. Subtract the 9. Then divide by 3. Any flipping for dividing by 3? No. So if what we write down is positive, there'll be no flipping. Now these look kind of backwards. Shouldn't the less than 1 be over here and the greater than 1 be over there? And the answer is you're going to get the same graph. However, we really do want you to put these in the order they would be in on the number line so you don't mess up. Because every once in a while, somebody does one of these in the homework or does it on the test and their arrows are both pointing the same direction. And and it's supposed to help you say to yourself, oh, this is good. The arrows are pointing in opposite directions. Open or closed at -1. Open, no equals bar. Shading which way? Left. To the extremes. Open or closed at 3? Open. Shading which way? To the right. The oars. Out there. Left and right forever. Ands and sandwich. Oars, that away. So and or. Those are our big compound inequality. Oh my, no way. We're done? We're done. Do I need to make up another one of any of those? You feeling good? Okay, so which one graphs like this? Okay, this is your and. Remember that. Your and should always look like you're graphing that sandwich. Yeah, that looks bad, and that's because I didn't want to say do 25 to 78 all, because that would have been bad. So you don't need lots of practice. So that's why it looks bad, because I was just nitpicky about which problem had something a little bit different going on in it. Now again, I want to remind you, got to do the homework to get that into the long-term memory. And please, please remember for attendance, I cannot mark you present on the days that you are not here unless I get the product from you, and the product is the homework. You need to know Schoology is very, very slow right now because, you know, everybody in the nation is like submitting things into Schoology. So if your attendance gets messed up and your parents say something, just say, Mom, Dad, chill out till Friday. If Cedar Home doesn't get it fixed on Friday and we don't see a change on Monday, then yeah, you can call or you can email. But sometimes during the week I don't have enough time to get all of those little attendance things changed, and I have to hold off on some of them until Friday. And add to that when we make the changes, Campus and Schoology need a night to change it over. It's not like we make the change and it immediately goes through the system. Everything is slowed down for